Okay, so hi, good evening. Can you hear me?
Yes, sir. Good evening.
Yeah, how are you?
I'm doing great. How are you, sir?
Yeah, I'm fine, thank you. Okay,
Yes.
okay, hope everything is good from your side. So basically,
Yeah.
today we discuss about that forest resource management, and after that we have time. Then we'll also talk about the other topic. Okay, so let's go start one by one, and then we'll start. So let me share my screen.
Okay, sir.
Okay, can you see my screen?
Yes, I can see.
Okay, thank you. So let's go. So okay, we start from here. Okay, we start from the first introductory part and start. So basically, forest resource management using remote sensing. So basically, it's cover a lot of topic. When you work with remote sensing for forest resource management, we need to work with forest cover mapping, then deforestation and degradation monitoring, then biodiversity assessment, then carbon stock and biomass estimation, forest fire monitoring, as well also illegal logging detection, forest health and diseases monitoring, ecosystem service monitoring, habitat and wildfire monitoring. So land use, land cover classification, monitoring reforestation and afforestation. So it consider lot of topic, soil and water conservation in forest area. So this type of things I will try to explain in this online training program, and I hope we can easily learn all of those practically also. So let's go start one by one. So forest resource management. So basically, it's one kind of sustainable planning, monitoring, and utilization of forest resources, and it's really important for biodiversity, carbon sequestration, timber, and ecosystem service. And in this case, we try to work with monitoring change and informing decision how we can easily take using the remote sensing technique. Okay, and also use here the different types of diagram of forest ecosystem benefit. We also discuss. So first of all, we in this case we are using the different types of satellite or aerial imagery to gather the forest data, and then we try to it easily cover the large scale monitoring and timber efficiency and cost effectiveness, and
Sir,
we can easily use here the Landsat, Sentinel, Modis, or LiDAR. Yes, please.
sorry, sir.
Yeah.
When you're talking about aerial imagery, you mean the drone image, is it?
Yes. Yes. Yes.
Is it possible to process the drone image using the Google Earth engine, or we have to use
Yes.
this
Yes.
other
Yes.
software?
Yes. Yes. It also possible. So we can easily convert it into GeoTIFF file format. Okay. So then we can
Yes.
easily work with Google Earth Engine. All of function you can easily work with that, but we need the
Yeah.
GeoTIFF
Okay.
file format for that. Yeah, it also possible. An application of remote sensing in forest. So basically, forest cover mapping we already discussed. Then biomass and carbon stock estimation. Then biodiversity and habitat analysis, forest health monitoring, sustainability forest management, disaster response such as fire detection. So forest cover mapping, we already know about that. Forest cover mapping basically we are using the different types of satellite imagery, such as Landsat, Sentinel, MODIS, or any kinds of aerial photography or drone imagery. Okay, for the forest area we can also use for making the forest cover mapping, and also method we can easily use here the different types of method. If you want, you can use here the different types of indices, suppose NDVI or classification algorithm or change detection. So this type of algorithm we can easily use, and further we can easily identify for deforestation tracking area or reforestation tracking area, and further we can easily visualize all of deforestation and afforestation area in the forest cover mapping. Okay, so here you can see this is the one kind of example. So it's the forest density mapping. We can easily create it using Google Earth Engine. So we can easily identify where is the high density of vegetation, where the medium density of vegetation, where the low density of vegetation. We can easily monitor using this process. Okay, as well as you also calculate the area. Suppose how much dense vegetation, high dense vegetation area, low dense vegetation area, or medium dense vegetation area for any forest covered area, we can easily detect. So I also show you a theoretical part, then I also try to show you some practical application. Then I hope you can easily get the more better idea how it will be work. And also deforestation monitoring. So here you can see for the deforestation monitoring for the different time period. Suppose 1990 to 2020. Okay, so for the different time period, the deforestation area we can easily monitor using the Google Earth engine, and it's very essential for that monitoring the forest cover mapping or forest cover changes, how much area deforestation, how much area afforestation or reforestation. So we can easily detect from here using the Google Earth engine also. And if you check the area, suppose here you can see the forest area. So we find out that 1990, then 1900, suppose 95. So you can see sometime forest area is increasing or also decreasing. So we can easily get the decision from here how much forest area is increasing or decreasing. So this type of idea we can easily get it. Okay, when suppose in this case this analysis I try to focus forest area from 1990 to 2020. So between this time period, what the scenario of forest area changes, we can easily get it from here. So you can see sometime forest area increasing, we find out, then you can see the decreasing, decreasing, decreasing. Okay, so you can easily get this type of things from here. And this is the forest area from 1990 to 2022. So you can see also afforestation. So basically these things I already discussed for the previous session, how we can easily make the afforestation and deforestation mapping for a specific time period. Suppose in this case we are just consider 1990 to 2023, how much area, how we find out that afforestation area. So basically this type of green color indicating about the afforestation area, and this type of red color indicating about the deforestation area, and white color indicating about the unchanged area. So in Google Earth Engine platform, we can easily create this type of things and identify afforestation, deforestation, and unchanged area for a specific time period. So this is the another application of forest monitoring using remote sensing. As well as you also calculate the area, suppose how much afforestation area, how much deforestation area, how much unchanged area. We can also get this type of information also from Google Earth engine. As well as we also do for the biomass and carbon stock estimation. Okay, we also do using the Google Earth engine. Different types of indices also used in here, suppose NDVI or soil adjusted vegetation index for biomass estimation. We can also use here the different types of LiDAR data or radar data, mainly SAR imagery, to detect the forest biomass and carbon. Application, we are using here the carbon credit project. We also apply this type of technique and visualize the carbon stock distribution map. Suppose here you can see this is one kind of map. So it's called that above ground biomass density. Okay, so this type of things, in this class I will show you that how we can easily create this type of above ground biomass using Google Earth engine. So this is the one kind of project work for us. So this is the main above ground biomass density, milligram per hectare. So this thing I will try to explain about that. So I hope you can get the idea how we can easily create the biomass mapping. So basically AGB, it means that above ground biomass. It's the total amount of living and dead plant matter above the ground per unit of area. Okay, so it includes the stem, branches, leaves, seed, foliage, and bark of trees and shrub. Okay, so basically it's the total amount of living and dead plant matter above on the ground and per unit of area. Okay, we measurement these things per unit of area. And basically it's the important for many region including for carbon cycle, because above ground biomass is a key part of the terrestrial carbon cycle. Then crop yield, so basically above ground biomass is used to estimate the crop yield. And also forest timber, suppose it's also used to estimate the forest timber production, as well also posture forest. So basically is estimate the posture forest we also do using the above ground biomass. And this is another important things, it's called the blue carbon storage. Okay, so basically blue carbon storage, we can also do using the Google Earth engine platform also to identify blue carbon storage, how we find out the high blue carbon, how we find out the low blue carbon, So basically, blue carbon refers to the carbon capture and stored in the coastal and marine ecosystem, such as mangroves, salt marshes, and the seagrass beds. These ecosystems play a significant role in mitigating climate change by sequestering large amount of carbon dioxide from the atmosphere and storing in their biomass and sediment for the extended period. And ecosystem contribution for mangrove capture and stored the significant carbon in their roots and trunks and sediment, as well as also seagrass act as underwater meadows, also trapping the organic carbon in sediment. And for salt marshes, basically store the carbon in plant matter and pit soil. We find out that in the salt marshes area it is stored the carbon. And forest health monitoring, so basically for the monitoring forest health we are using the different types of technique. One kind is called the spectral analysis for diseases, pests and drought. So spectral analysis we do, and then we can easily identify for diseases, pests and also drought. And we are using the different types of satellite imagery for that, and also early warning system for the forest management. For forest health monitoring we also use. And further you can see this is the one kind of forest or agricultural land area. So basically we can easily use this type of index. Suppose it's called the green chlorophyll vegetation index, so we can easily identify for crop health. So this is very essential to identify for crop health and productivity. We can easily getting the idea when you apply the green chlorophyll vegetation index time series for your agricultural land or any forest area. So then we can easily identify the forest health or also crop health or productivity. Okay, so basically this type of in this case you can also add the time series chart, and you can easily identify when we find out the peak stage of the green chlorophyll vegetation index. Okay, when it will be low, so you can easily get this type of idea for a specific. So it's one kind of method to identify for crop health and also productivity using green chlorophyll vegetation index. As well as we also use here the modeling of leaf area index in Google Earth Engine. So it's another index, it's called the leaf area index. So using the leaf area index we also monitor the crop health or productivity, which crop agricultural production. So this type of things we can easily monitor using this index. It's called the leaf area index. So I'll also show you the further project work how I can easily do this type of things practically. So basically leaf area index, it's one kind of key biophysical parameter in ecology, agriculture and environmental studies. It measures the total one-sided leaf area per unit ground surface area. Okay, and it's essential for understanding the plant growth, canopy structure or photosynthesis, transpiration, carbon and water cycle. It's very important. And higher value indicated the denser vegetation or denser canopy cover when you find out the high value. So basically you find out the value 0 to 10. So basically 0 is the bare ground or barren land, and 10 increasing dense forest. Okay, so 0 to 10, so increasing for the forest or dense forest increasing. 10 is that increasing or more than 10 value of leaf area index indicating about the dense forests. An application for agriculture, we also use this for monitoring crop growth stage and health. As well forestry, so basically assessing the forest density and health. And also climate studies, basically modeling energy and water flux in ecosystem. And hydrology, so basically estimating the water interception and evaporation, we also use it for that. And sustainable forest management, it's another key concept of forest resource management in Google Earth Engine. So basically we can easily do zoning forest, basically conservation area or logging area, agroforestry area. So this type of things we can easily monitor using this technique. Also we have to use here the different types of suitability analysis using the different types of factor such as elevation, then proximity to road, proximity to river, proximity to major road. So this type of things we also use to identify for suitability analysis. And also use the community forest and sustainable yield planning. So here you can see this is the one kind of example for illegal logging detection. We also identify, suppose illegal detection. this type of things we also do using the Google Earth Engine also. So I'll show you the practically how we can easily detect. And also you can see the basically illegal activities is that one kind of activities such as deforestation or logging or mining or land encroachment or using remote sensing GIS tool involved. We can easily identify using the satellite imagery to monitor and identify and quantify the changes in the land use and land cover. So in this case, this is the one kind of example. So basically in this case, I use here the Sentinel-1 SAR data, and further we try to identify illegal logging detection, as well as we also do for the suitability analysis using Google Earth Engine also. So it's one kind of another advanced technique in Google Earth Engine we also use to identify. It can also apply suppose in the forest area where you just identify cropland or suitable cropland for plantation crop. So this is the one kind of hilly region in Bangladesh. So basically in this case we try to identify where we find out that suitability for agricultural land. Okay, suppose you can easily find out this type of place, we can easily find out that it's highly suitable for agricultural land, also moderate, marginal, low, and not suitable. So this type of things we can easily do using Google Earth Engine, and further we can easily take the decision how I can where we find out do for the agricultural land. Okay, we can easily get this idea from here. So it's one kind of suitability mapping, but using this process you can easily do any kinds of suitability analysis, we are just applying the same process. So as well as disaster management, suppose application, suppose real time forest fire detection, flood impact on forest. So this type of things we also use in forest resource management. Suppose we can easily identify for real time forest fire detection, or also past time for forest fire detection, and also flood impact on forest area. So this type of things we can easily do using Google Earth Engine, and so help of remote sensing technique. And we will use here the different types of data. Suppose for the fire we can easily get the data from the modis for fire, because we can easily find out the modis for fire, or Sentinel-1 for flood mapping, and benefit rapid response and damage assessment we can easily do using that. Suppose here you can see this is the one kind of forest fire, basically bushes fire in Australia. So we can easily identify this type of place, we find out that fire, we can easily identify this type of place. Okay, and we also create so you can forest fire data. Suppose you can see this is one kind of forest fire data for that Australian, we can easily find out this type of forest data. So this type of things we can easily identify from Google Earth Engine, and further you also use it. And also it's very important, it's called the forest fire risk mapping. Okay, suppose we can easily create where is the high risks of the forest fire, where is the very high risk, where is the moderate, where is the low, where is the very low. So it's one kind of forest risk mapping, and it's very important to early warning system. Okay, so we can easily identify this place is for the very high forest fire risks, this type of red color indicating about that very high forest fire risks, then this type of color indicating about the high, then yellow is indicating about that moderate, then green is indicating about that low, and then this type of color indicating about that very low. Okay, so using this technique we can easily identify forest fire risk mapping, and then you also take the early warning system for this type of place, then it also not get huge of damage. Okay, so this type of things we also including for our forest resource management using Google Earth Engine. So now I will try to explain all of practical session. So I hope you can easily get the idea how we can easily create this type of work using Google Earth Engine and help of remote sensing data. Okay, so let's go start. And I will send you this type of slide, so further you also try to read it all of things properly, and then
Yes.
this type of things you also try to apply for your own study area. Okay, and then face
Yes.
any problem, then I also guide you, no problem. Okay, so
You're
let's go.
okay, sir.
Okay.
Thank you.
Okay, so first of all, I try to discuss about that forest density mapping, how we can easily create the forest density, high density, medium density, low density, and as well as how we can easily calculate the area of each density. Okay, so let's go. Then we talk about the deforestation monitoring. So okay, let's go. Let me open my code. So vegetation index, when you want to identify vegetation density, then we also use at the different types of index. So it's simply I search here, suppose vegetation index, I simply search here. So then we can easily get some idea. So if you check, suppose let me open from here, measuring vegetation.
Sir, can you increase the font size,
Okay,
please?
just a minute. Just
Yes.
okay. So here you can see, just I open the code. So in this case, this is our result. So in this time, from here we can easily get the idea. Suppose why do you find out that high density. So basically this type of green color indicating about the high density of forest, and this type of yellow color is the low, medium, and this type of color indicating about the low density. Okay, so we find out that low density of forest for this type of place, as well as you can see the result. If I check how much vegetation will be changed, we can easily get the idea from here. So in this case we are just use here the NDVI. So basically we are using here the different types of index to identify for forest. Suppose NDVI and EVI. If you want, you can also apply the EVI, there is no problem. Basically EVI is when you apply the EVI, then you also get the more better spectral signature value, and it's also create the more better map you can easily identify. But NDVI normally we try to use, and NDVI is an indicator of drought, enhanced vegetation index, EVI. So you also try to read this type of things. I also attach in my thing, then you also get the more better idea what the difference
Yes.
between the NDVI and EVI, and when you need to use the EVI and when you need to use the NDVI. Then you also get the clear concept about the EVI and NDVI, and further from I can easily use it. Okay. So in this